There we go. Sorry about that. That was a great joke if I didn't totally flub it from technical difficulties. So yeah, it's really cool that I get to work on open source all the time. And I want to take this opportunity to thank everyone in the room, because your continued interest in Solidus makes that all possible. So thank you. And I really love open source. It's a really cool way to write code together with people all around the world. And when I first started working on Spree about 5 years ago, I thought it was a great field and a great opportunity to do open source work. Because not only is e-commerce a large field where monetization is really obvious, you sell things for money, but there's a lot that all of our stores have in common. We all have, the stores are going to look very different, but you're generally going to have a checkout, take payments, do taxes, and then have stuff surrounding that, like needing an admin so you can do customer service. And eventually you're going to grow enough where it would be nice if we had an API around that our JavaScript could hit, and other things like that. So it should be a great opportunity to write code together. And not just to write code together, but we can share onboarding efforts by writing good docs and guides, and business requirements for one thing may translate to the others. So it's a really cool place to try and explore that. Now, kind of paradoxically, we also have a lot of things not in common. And that's one of the things that I think brings us all to the Solidus platform, is that it's designed to have heavy customizations. So we're all going to have, and I think we've learned a lot about this from the talks we've had yesterday, and we'll learn more about the talks later. We have different CMSs that run different stores. We have different tools for searching, for analytics. We run different payment gateways. And all that's possible. But the goal of working together is still there, because a lot of us are going to run the popular payment gateways, for example, like Stripe and Braintree. And if someone has a great integration for CMS, we're going to want to use that. So we end up making extensions, which bridge the gap between customizations that are only useful for a very particular store with very particular needs, and things that not absolutely everyone needs, but certainly more than one person. So could I get a show of hands for who has made or contributed to an extension? That's quite a lot. It's awesome. Now, who would say they're 100% happy with that extension and how the overrides were done? Right. Absolutely no one. That's good. That's what I'd expect. My hand's not up either. You're not a bad person for having used class eval. It's OK. We need to find ways to not use class eval. I think that's a common goal. But we need to find those together. And I heard too many people come up to me in the past couple days saying, I've got this extension, but I don't know if you should use it, or I'm not sure it's up to the code standards of the others. I'm sure it is. And if it isn't, there's no judgment here. Let's get these extensions out in the open and work together to make them as good as we can. So I wanted to go back to when I first started working on Spree, about 5 years ago, just so we could see where we've come when we make extensions. So when I first started working on Spree, we did something that, if you're new to Solidus, is going to seem quite odd. For each extension, we had a branch for each Spree version. So if you were using version 2.2, for example, you would have to include the 2.2 stable branch for every gem you wanted to use and reference the GitHub. And this meant that you weren't working together with others if they were on a different version. And as well, it was not really compelling when working with a gem to upstream changes, because you might be stuck on 2.2 for a while, and changes that would get merged might not be backported to the 2.2 stable branch. So you might just put them in your own fork and not bother with the effort to get them live. And that sort of just spiraled, because then upgrading was very challenging. If you wanted to upgrade Spree, you also had to upgrade all your extensions. And because these extensions had changes that weren't necessarily backported, you were upgrading all your extensions at the same time, as well as Spree at the same time. And that's a big unknown. And extensions can move pretty quickly, just because they target a more specific thing. And you might have to port this extension to the new version yourself if no one had gotten to it, or if because of like I said before, you hadn't bothered to upstream the changes you made to the extension, you would then have to make a new branch on your own fork which had those changes. So this was unfortunate, but it didn't seem to me like at the time out of place, or like there was another option, because and partly because of the way we were doing all our extensions, which was through mostly heavy class evals. Instead of, well, it was really the only option we had for a long time, which was to, if we wanted to, for example, change the way a line item's price was calculated for a bulk discount or something like that, you'd want to copy in the code from core and then add your own code after that and replace the entire method. So if there were changes made to copy price, then they would not work in the next version. You'd have to make a branch with the specific code copied correctly from the version you're trying to target. So when we started Solidus, one of our goals was not to do this. We wanted to have our extensions work across multiple versions. And this would allow us to upgrade the extensions separately. So you could PR code into extensions and then upgrade, and then you'd get that new code right away. But also, you could upgrade your gems separately from the store. So that would keep your production deployments to be as unterrifying as possible. The less things that move, the more confident you can be about them. So when we sat down to do this, I did not know how. Had just no idea. But fortunately, I often have no idea how to do anything, and the answer is usually to write tests. So as long as we had one solid test for the integration, or how the extension was being used. For example, overriding the price, I'd probably want to test order contents add and make sure that when you added an item under the right circumstances, it did in fact apply the custom price. So what I then did is looked in the environment inside the gem file for a version to be specified, and then to use that version. And then from our Travis configuration, we could test multiple versions. And initially, this wasn't a big feat. We just started with testing 2 versions, and it worked. So, okay, let's see how far we can ride this out if it works. And it's worked to this day. So we've never, in many of our gems, we haven't had to drop a single version. And the same code is compatible across all Solidus releases we've had. Later created extensions.solidus.io, which is much less impressive than it looks. It's just a rake task that dumps out an HTML page that looks like this by looking at the results from Travis. And it's really cool, and it's gained a ton of gems. And it could have more. Your gem here. There's no requirements to be up here. Don't worry about code quality. Let's start working together to make them as good as possible. All we ask is that it passes on the latest version and master and test to run. So obviously, sometimes things break in the way we add extensions. So how have we worked around that to make them compatible across versions? Well, the simplest thing we can do is to just run different code based on what version we're on. And yeah, that's a little gross, but I think it's still better than having entire different branches, because this is a small piece of code that may have needed to be different rather than changing out the entire branch you're using. And this is a worst case, I guess, but I don't think it's too bad. More often, what helped us was avoiding copying in code by using module prepend. And this was available to us because Ruby 2.0 became ubiquitous and necessary for modern versions of Rails. So instead of this old class eval where we had to copy in the code exactly, we could call super and make a module. And this is only, it seems only somewhat better, but this means we no longer depend on the exact code inside there. As long as the method name stays the same, we should be OK. It also works, it's a lot nicer for debugging tools. If you use pry show source and show source-s, that's good stuff. So by doing this, we've made our extensions backwards compatible. And that's great. I don't want to just breeze over this. I think having them backwards compatible is awesome. It's allowed those targets we had of being able to upgrade the gems without upgrading Solidus. I think that there's more motivation to commit your changes back to the gems, and I hope that happens. But the techniques, it still leaves something to be desired. Backwards compatibility doesn't really, the techniques for it don't really apply to stores. You're never going to downgrade the version of Solidus your store is running, I hope. But I think, thinking about it more, what we really want is forward compatibility. We want to be able to write code once and run it forever. We don't want to have to look for failures in that big build matrix and then patch our extensions so they barely work after we release each version. And doing this is hard because it seems like you'd have to predict the future, but it seems like you'd have to predict the future or be extremely careful. And I thought about this some more, and it seems like this is some of the things Cember is supposed to give us. Now, Cember is a schema to format your versions that guarantees that only major patches should break backwards compatibility. But it certainly didn't, and we were trying to follow Cember, but it certainly didn't feel like we were getting that promise out of it. So what were we doing wrong? And I think the key to that is what we would consider to be the API that we're breaking. Now, what the API is in a REST web service, for example, is obvious. It's the request, HTTP request, and the responses. When you think about it for a piece of Ruby code or code in any other language, it's the public methods, what arguments they take, and vaguely what they do. But once you throw overrides into the mix, suddenly private method names might not be able to change. You might be calling them, you might be overriding them. What the method does exactly might start to matter. If we called copy price twice, that if your bulk discount is done by taking 20% off, and we used to call copy price once, and we start calling it twice, that might be very bad for someone. And the result is that to have a consistent API for what we expose to someone using class eval is that the source code can't change at all. The API is the source code in full verbatim exactly. And obviously, there's no way forward maintaining that. So I think the only option is to try and avoid overrides. And as a community, we're addicted to overrides. It's the first hammer we always reach for. Here's a few examples. In Enceladus product feed, which is a gem which generates a RSS feed consumable by Google for that product thing they do on the search page. What this gem did is it added the RSS format to the existing products controller. It would check on the index action if the format being requested was RSS, and it would load products in that case, and then it had its own view and stuff. And this was just totally unnecessary. We could just make our own controller and respond to RSS and do the normal stuff, and the only difference is that the URL changes. And since this is just a URL we're typing into Google Analytics, it really doesn't matter. And another benefit is that this works even if you're not including our standard front end. And as well, if you're on rig routes, it will show you the thing that makes sense. It's just better in every way. And you can't, I totally understand why it was written the other way, which is that you're thinking, well, I need to make an extension. Extensions have class eval. That doesn't have to be the case. Just if we try to use it as little as possible, I think we'll come up with good things. It's not an isolated incident. Solidus i18n added this, which added an extra callback to the update action on general settings controller, which worked great until I deleted the general settings controller. Because we no longer have general settings, we only have store settings. And instead of doing that, the fix was to make a new controller, which only handled the locale settings. And this is there's more of a trade-off here. Before we had that setting on one page in the admin, and that's arguably nicer. But it wasn't that much nicer that it was worth compromising our code quality for, especially since the settings changed once ever for most websites, and it probably shouldn't even exist. And these are easy examples. It might be unfair for me to pick them, but they are things that we had for a long time in those gems. And I think one of the things that was really helpful in fixing this is to try and use the namespace for our gem. So this one, we've made a controller under Solidus i18n, and it really now feels like it belongs because we've made a class inside of our gems namespace rather than inside the old Spree namespace. So we're just trying to keep things more separate. And so again, these aren't totally fair. They're totally adding value. In fact, that Google product feed one, I assume everyone should be using that gem. It just does the right things. But oftentimes we're not simply adding a new page or adding a new feature that's totally separate. Oftentimes we need to customize existing behavior. And that's why we wanted extension points, which were sort of a nebulous idea of we want some classes that generally do the things we want and we can configure them. And this finally started to click for me when we looked at the stock estimator. The stock estimator is one of our classes inside the shipping stuff, which calculates the shipping rates. So there's a Solidus Easy Post gem, which instead of calculating shipping rates the normal way, would make an API request to Easy Post and return the rates from them, which is pretty cool. Now, Brendan did this, who's been manning our counter for the last 2 days. Oh, he's at the back now. He made it so we could swap out that class for a custom one. And it's super, it seems pretty similar. We've lost a class eval, and if that was all, this might not be such a big deal. But it actually opened up even more possibilities. We'd had people interested in using the Solidus Easy Post gem, but couldn't because, well, Some of the rates might come, we want some of the rates to come from EasyPost and some of them to come from the default store or the vanilla Solidus database. And to do that in the old extension, it would have to be some configuration option or something like that. But by moving this to its own class that we can swap out, it was really easy to compose the two implementations together. So here we make a my custom estimator, and you'd probably do this in your store's application itself. And you would fetch the vanilla rates using the class that's built into Solidus. And then you could fetch the EasyPost rates using the EasyPost thing, because you've included the gem. And then you just add them together because they're an array. And you'd swap out your own custom estimator because you can, and it doesn't, there's not a class eval that's forcing you to use the new code. You can programmatically set it to use whatever code you want. And I think that you could probably build even more estimators on top of this. You could use it to sort them in the way you want. You could use it to pick the default. And previously, these were things where the only advice we had on how to customize that was to class eval some private methods that were on the estimator. So I think this, once we started doing this, I thought we were really, really onto something good. And on top of that, we can make this backwards compatible quite easily. We can check if our Solidus version doesn't support this new customizable class, which was added in 1.2. And if it is, we can just add an override like we would before. And this code doesn't, to me, doesn't even look weird. I think we could have started with this originally in the gem. And I think it's something we should try to do in the future to try and find the best places to make these extension points. If we put as much code as possible into the namespace of the extension, we're going to have an easier time figuring out the best way to call into our custom code. Finally, inevitably, taxes, specifically external tax services. So taxes are really hard, especially if you're shipping to the US, where every zip code may have a different tax rate. So it's necessary to call it, or hugely desirable to call it to an external service to do all the work for you. And this has existed the whole time I've been using Spree and Solidus, but has never really been easy enough to use or done in a satisfactory way that there weren't caveats and weird things that happened. So what we originally started with was the way tax updates would be performed was to look at each item on our order, each line item and each shipment, find the matching tax rates for that item, calculate the tax amounts, which is pluggable, and then to create adjustments from that. And that works great for the vanilla way we do it, because it's very fast to look up tax rates in the database, and we actually do want to do it for each item because we're writing all that code. So that for loop's going to exist somewhere. But when you're calling out to a tax service API, they really want to take the whole order and then give you back the amounts you want for the item. So how this was done for a long time, and still today in many extensions, is to loop over each item, and for each item, calculate the rates for the whole order, and then find that one item that you were actually supposed to calculate the rates for and return that amount. And this, yeah, that's horrible. And we can cache that lookup, but that's gross. And until Jordan made some awesome fixes, that also didn't work at all. So we knew that wasn't enough. So as part of one of the tax refactorings, we moved that extension point higher up, where instead of using the calculation per item as the pluggable component, we plugged out the whole tax calculation. So we just had a class and we said, please add taxes to this order somehow. And that works a lot better. We can now make a single API call. No need to cache, although it might be desirable. But it's much simpler. You get the items back, and then you can loop over the rates you got back and apply them to the item correctly. But applying the tax rates correctly when you're supposed to create the adjustments wasn't ideal for a number of reasons. Martin thinks at some point we should lose adjustments for applying taxes, which is probably a good idea, but I wouldn't panic about that happening yet. But more so than that is it felt wrong learning what we learned from the shipping rates, where because that had returned values that weren't directly saved to the database, we could manipulate them further before we saved them. And as well, there was another thing, which was that it's a little bit of code to create tax adjustments efficiently. If you recalculate your tax rates and just get the same amount back, you don't need to wipe out the tax adjustments and recreate them all. You can just say, no, we're good. I checked. We're still up to date. And over our SolidusConf hack days, we finally have a good solution. And thanks to Adam and Jordan and inevitably Martin, because taxes were involved, and many others who looked through this and provided ideas and suggestions and help. What happens now is that we have an extension point to calculate rates for the whole order and return those rates as plain Ruby objects. And then a class we have in Solidus, which will create the adjustments based on that accurately. And it reads really well. I recommend everyone go check it out. It's really cool. And I think it might be early to declare this perfect, given that it's been merged for a whole 2 days, but I think we've nailed it this time. And one of the best parts about this is because we've been using classes for adding all of these extension points, even though we've made them, maybe slightly wrong at the wrong granularity or doing the wrong thing, all the extension points still work and coexist without any issues. Each of the new ones, by default, simply calls the old one because they were doing the right thing. So you can still override any of them and it will work. This has been something that we've needed for 5 years, and we only got it 2 days ago. So the takeaway I want to have is that it's hard to write extensions, but there are solutions, and we can find them if we work together and try and do our best. Thank you.